Wrong one, ladies and gentlemen. Here we go.
Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome to the program. You ever just wake up some days and technology just decides, today is not your day? That might be that might be this day. So everyone, we're going to try to get through it, but everyone, welcome into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. To our podcast, everyone, welcome into the program. I hope that you've been well and you have been keeping busy. And today on the show, we have the one, the only, Mr. Ralph Bond. He is our science and tech trends correspondent, and he, of course, joins us to talk about all things science and tech oriented. So if you think about really a lot of the announcements and a lot of the research and, just a lot of the stories that are out there, hey, he can pretty much talk about anything he wants, but he chooses 4 great uplifting stories that are meant to, take you into a Friday, take you into the weekend, a little bit more cheery than maybe you left the week. So with that being said, we'll get to Ralph in just a moment, but before we get to that, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, podcasts, videos, archives, everything, and I need to emphasize the show notes. You can, of course, find that there, and that will have everything that we talk about, including links to articles that are more in depth than what we do. Ralph does an amazing job of getting, great bullet points. And if you want to find out more, you can always go to the show notes at computeramerica.com to find those out. By the time that you are hearing this, those show notes will be out. So everyone, once again, welcome into the show. I hope that you, I hope that you do something fun this weekend. And in the meantime, we will go ahead and kick this off with Ralph Bond. So, Ralph, welcome back onto the program. How you been?
Okay, good. I've been doing great, Ben. I know what you mean about pesky computer problems. It's okay if my computer has a problem, so long as it's legitimate. But when you have these mysterious problems, like you were wrestling with before we went on air today, that's when I get really frustrated. It's like, what? Why?
It's when you have the problems that you know the answer to, but the answer isn't working, and it's like,
well, that's another one, yeah.
And just to fill everyone in, like seriously, this may strike a chord with a lot of people out there. It was something as simple, like the thing that delayed the recording of the show was as simple as I could not get a window to show up on the monitor. It was going off into the abyss somewhere, and Windows shift left and right in case anyone out there, you have multiple monitors, and let's say one of them is turned off, the program goes to that second monitor and you want it on your main monitor. Normally, Windows shift left or right changes the monitor that program is set to. So if the monitor's off, you can switch it over. May help you out there, but for me, it did not help today. So Ralph, I'm going to say the tech gods just are not with me today, and that's okay because we're gonna do our show and we're gonna have fun with it either way. So for those out there who may be first time hearing Ralph, you're in for a treat. So Ralph, go ahead and give the nice folks a rundown of what we try to do here.
You bet. And this is especially good for our friends who are joining us for the first time, especially if you're listening as a podcast, as Ben mentioned. Come out to computeramerica.com, get the show notes. Very important. You'll have the images, the links, and so on. But what Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, space research, physics, you name it, all across the board. And most important of all, as Ben was alluding to, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And it has a lot to offer us, which you've chosen 4 great stories. I think we're going to go ahead and start with a place a little close to home for you. And I love that you're so in touch with the Pacific Northwest National Laboratory, because they do such fantastic research, and it's always nice to kind of see that, hey, they're keeping their students busy, they're keeping the research coming. Well, I guess students, I'm sure there are grad students there, but yeah, they're not a university, they're a laboratory. So but still, let's go ahead and head on over to there in story number 1.
Yes, story number 1. The headline here is More Sustainable Tires. So we're going to get real here. Tires and rubber meeting the road, so to speak. So headline, More Sustainable Tires in Sight as Pacific Northwest National Laboratory and Bridgestone team up. And this is a really fun story because it's got a lot to do with sustainability and also very real. I mean, tires are very real to all of us in so many ways. And in the show notes, if you come out to computeramerica.com, get the show notes, there's a great illustration from their research paper that kind of captures the essence of this. And it's all about, we're going to talk about all this technology they've developed to take ethanol and turn it into a key ingredient needed for synthetic rubber. But I'm jumping ahead here. Let's get into the story. In the near future, tires for cars, trucks, airplanes, and more could incorporate synthetic rubber made from plant matter, waste, and even recycled tires, thanks to a new eco-friendly technology innovation. So side note here, and this is one thing I do with the show notes, by the way, I take the bullets, the essential kind of condensed information from each article, but I also inject things to help augment. So a little side note, about 60 to 70% of the rubber in a modern tire is synthetic, and synthetic rubber is favored due to its durability, consistency, and quality, and lower cost compared to natural rubber. So a little sideline there for a second. Now here, back to the story. The Department of Energy's Pacific Northwest National Laboratory is teaming up with Bridgestone, one of the world's largest tire makers, to scale up a new, groundbreaking chemical process that converts ethanol into butadiene. And I hope I'm saying that right, folks. It's spelled Butadiene, butadiene, synthetic rubber's most important ingredient. And let's see here. Yeah, pretty cool, Ben. What I love about this story, Ben, is it's just so related to reality.
Yeah. And no, just looking at tires, and they have one of the pictures up there on the screen in the article, and on top of that, anyone out there who's just kind of driven around and see these giant piles of used tires and tires that are just either destined for, or hopefully, recycling and reusing. But I don't know, Rob, but like this is such a I don't know. You kind of think that, you only go through tires like once every 3, 4, 5 years. I don't know what the actual, amount that you're supposed to go through. It's like, 4 tires every 3 years is kind of whatever. No, we use so many tires, and this is going to help so many, hopefully cut down on all of that waste and, really help with that. This is very important. So cool.
Yeah. And going back into the story here with another little side note, because again, this is talking about creating ethanol through a lot of sources, and then turning that into an ingredient you need for synthetic rubber. But another little side note here, a reminder, ethanol is produced through the fermentation of sugars by yeast with raw materials that contain fermentable sugars or carbohydrates. And common sources for ethanol include corn, sugarcane, wheat, and barley. Ethanol can also be produced from other types of biomasses like algae, food scraps, and even wastewater treatment sludge. That's how ethanol is great. You can make it from so many different things. I just love it. Yeah. But going on here now, traditionally, butadiene is created as a byproduct of a process called steam cracking. So what's that all about? Well, in a refinery, crude oil made of long chains of hydrocarbon molecules is heated and combined with steam to destroy chemical bonds and create smaller hydrocarbons. Further refinement of the smaller hydrocarbons produces ingredients needed for a host of products such as plastic food packaging, synthetic fabrics, fuel for cars, trucks, and rubber tires. So the key here to keep in mind, folks, the setup, so to speak, is to date, it's been a costly, difficult process involving steam cracking. And that involves crude oil as well as heat and so on. So keep that in mind as we go on.
Yeah, you caught me somewhere in there that somewhere in this process, human waste and industrial waste through steam cracking gets turned into food packaging material. So good takeaway from that. I like that.
Yeah. So the result of this research that the Pacific Northwest National Laboratory and Bridgestone are up to is this collaboration between the two is to create a catalyst for the production of butadiene that cuts out the need for heat and the use of crude oil. Drum roll, please, applause. Which in turn reduces the carbon dioxide emissions of current production methods. Wow, so that's the big takeaway on this. A great example of research that's looking for ways to bypass heat. And you've got, how do you create heat? You're going to have to get some kind of energy, either fossil fuel or otherwise, to create heat, steam, and then the use of crude oil. Cut all that out of the equation to make a key ingredient for synthetic rubber, and you have something that has the potential to dramatically impact the entire world, because we got a lot of tires out there, as you were alluding to before. And by the way, one last little note, folks, if you're not familiar with the Department of Energy's Pacific Northwest National Laboratory, please go out to their website. I have a link in the show notes. I call these guys, and Ben knows this, the MIT of the Northwest of this country. They're in Washington State, and I just love these men and women. They're just amazing what they're doing.
They never seem to stop putting out, and I really enjoy that putting out great research, and then a lot of the research is kind of energy related. Obviously, being part of the Department of Energy makes sense, but yeah, they're kind of cutting energy, reducing energy, making things more efficient. They're very good at what they do, and I'm sure that the idea of cutting all the heat out of making the main component of those rubber materials is very attractive to a lot of industries. So very cool. Story number one, ladies and gentlemen, again, you can find that in the show notes over at computeramerica.com. Skipping on down to story number two. And this one's a little different because for everyone out there, it's we talk about a lot of different kinds of technology, and this one is a little bit out there when it comes to display technology and lasers and all that good stuff. Hey, maybe we'll see it next year at CES. Who knows? Ralph, story number two.
Yeah, story number two is great. It's from a really interesting outlet that I've just become aware of called Photonics Spectra. So that's the outlet, the online magazine. And the headline here is Scientists Develop Printable Droplet Laser Displays. And let's just step back for a second, a little context. The Consumer Electronics Show in Las Vegas just ended recently, and there is interest in laser displays. There are several companies now that have these. Think of them, they almost look like a sound bar. They're like boxes that you put on the floor below the surface that you want to project. And these laser projectors are becoming very popular and interesting, but they're very, very expensive. So this story caught my eye because there's this research going on that may, in my opinion, give us a future where that technology becomes much more affordable and can be scaled down into easily accessible consumer products that are not $2,000-$3,000 each.
Yeah.
So with that set up, let's jump into the story. And a little side comment from me, I think this is a key potential trend to monitor, Ben. Question would be, could laser displays be potentially the next big thing in consumer display technology? They do exist already, but again, as I said, they're very expensive today.
Right.
So when it comes to brightness and color reproductibility, if I could say that on Friday, laser displays have the potential to overcome the intrinsic limitations of conventional light-emitting devices such as organic LEDs and liquid crystals. Now, another little side note, we got to inject stuff because a lot of times when I'm going through these articles, Ben, I go, well, wait a minute. I need to understand a little bit more about the fundamental technologies we're talking about because the author of these articles that are very technical publications assume right? So a laser display technology uses laser beams to create bright, vibrant images and videos. And unlike traditional displays that use LEDs, light-emitting diodes, or other light sources, laser displays produce sharper images with higher contrast and a broader color spectrum. And this technology today, so far, is usually in very high-end projectors. If you're talking about a home theater, it's $2,000 to $2,000 on up. Digital signage, the really huge stuff, and large-scale event displays. So there's a little bit of background for you.
So it's not a
on those displays.
completely,
And I think you probably have seen laser displays and may not even be aware that you've seen them.
yeah. So it's not a completely unknown technology. It's out there. It's just like you said,
Right.
not consumer feasible. So
Yeah, not affordable. Let's put it that way.
Yeah.
So going on with the article, it says, however, to be effectively used as displays, and I'm going to insert my comment, for a wider array of commercial and consumer displays, in other words, to make it more affordable and practical for smaller displays, the laser display the laser display components must be miniaturized beyond current levels and laid out in high density and large quantities. That's the challenge, okay? And I did a quick search on Amazon for home theater laser projectors, and as I mentioned before, ones that can support 4K. And again, you're looking at $2,000 at the bottom and up. So it's a very costly technology right now for home use.
Yeah.
Okay, finally, with the story, with all that set up, rather, let's get to the news. Researchers at the University of Tsukuba, and I'm sure I'm butchering this pronunciation in Japanese. It's Tsukuba. So University of Tsukuba in Japan have developed a method for rapidly creating laser light sources in large quantities using, get this, an inkjet printer that ejects laser emitting droplets. Wow. If you go to the show notes, folks, again, computeramerica.com, you can see an image at the top of the notes and a little caption from one of the researchers, a comment they make. It captures the essence of what we're talking about. Check that out. Now, by applying an electric field to these droplets, the researchers demonstrated that switching the emission of light on and off is possible. And furthermore, they successfully created a compact laser display by arranging these droplets on a circuit board. Ben, that's pretty amazing stuff when you think about it.
Yeah, no, and seeing the image really, kind of highlights what they're, kind of talking about here. But to do that on such a small scale and to use, like you said, to use a 3D printer to hopefully, I guess, cut down, kind of cost in creating this thing. No, it suddenly becomes something that, Ralph, 10 minutes ago, a technology I'd never heard of. Now it's like, this might actually be coming to monitors near you.
Yeah, exactly. And I'm reminded of something we always say every week. And that is, most of the stories Ben and I cover are twinkle in the eye early research. And this is an example of this. So don't expect to go to Best Buy next week and pick up something for $500. No, that's not what we're talking about. We're talking about a big breakthrough in research that could set the stage for 2, 3, 4, 5 years out from now, a whole new generation of displays. So going back to the story, the researchers found that droplets of a specific organic liquid deposited by an inkjet printer emit laser light. These droplets are extremely small. They're only 30 millionths of a meter and can be densely arranged in large quantities over areas as large as several centimeters. So right now we're only talking about several centimeters. But again, the technology is setting the stage for the future. And Ben, you're going to love this part. When an electric field is applied to the droplet by positioning it between electrodes, the spherical droplet deforms into an ellipsoidal shape, causing the laser light emission to cease on and off, right? This demonstrates the droplet functions as an electrically switchable Let me try that again. This demonstrates that the droplet functions as an electrically switchable laser pixel. Wow, laser pixel.
Yeah, so they're saying that by applying, I'm guessing the current, because like the image kind of shows that a laser kind of emits onto the droplet, and then the droplet, I guess, amplifies it, or does the light actually come? I don't know. There's like the fundamental of this technology is getting by me just a little bit.
Me too.
Yeah, but no, it's still to be able to have these droplets either turn on and off just by deforming them. I mean, that's cool in itself.
Yeah. Well, yeah, and again, the droplets, as I understand it, are emitting the laser light. Now, again, this is a good point. The show notes, what we're telling you is just the highlights condensed down to a few bullets. We usually give you links to the scientific papers and the in-depth articles so you can understand better what's really going on in depth. We just want to tease you, make you think about this, and hopefully encourage you to go and learn more. But picking up back on the story, ultimately, the researchers were able to deposit the inkjet printed droplets with high precision, scalability, and the ability to switch electric fields using electrodes, though they did identify some areas where the method and design would need to improve. There's our reality check. And again, we're talking about very early research. The researchers at the University of Tsukuba say that once these needed improvements have all been achieved, the device's novel configuration should contribute to future advancements in laser displays, and that its liquid droplets offer potential for next generation optoelectronic devices, since the droplets can be integrated into existing organic electronics that are characterized by flexibility, adaptability, and biocompatibility. So there's a lot going on in this news that you could learn a lot more. We were just teasing you and hopefully getting you interested in checking out the show notes and learning more.
Seems like they left the door open there for everything from medical technology to display technology to so much more. So this is not just monitors, but like we were highlighting, but even beyond that. So very, very cool. And probably needs more understanding on that, but still cool. Story number 2, story number 3. Let's go ahead and move on down to this next one. And you love to bury stuff underground. It's probably the best place to put certain things. Nuclear things in particular work best when they are, a little bit more shielded, protected, safely underground. It's very nice. And, Ralph, and just, kind of teasing the headline here a little before you get to it, but data centers, they've been talked about a little bit. Especially with the rise of AI, and AI has been, let's face it, everywhere for the last 2 years, and the amount of energy that it sucks up, the amount of resources that it takes is, really. I saw an article the other day that some city was putting in the UK put in like a whole new. They incentivize, Ralph, people to come in and build data centers for AI to spur development in the UK. And now they're kind of setting up a fight between the water resources between the townspeople and the industry of AI data centers. Highlights that data centers need a lot of resources, and how do you get that kind of fairly and hopefully as securely as possible. And story number 3 might be just that.
Oh yeah, you're right on target. It's a great setup for this story. This one comes from interestingengineering.com, a great website. Headline: U.S. firm to bury nuclear reactors 1 mile underground to power data centers. And you're so right about the explosion in data centers. In fact, I live in Hillsboro, Oregon, which is just outside of Portland, Oregon. And if you look it up, Hillsboro has a ton of data centers. This is a really big deal out in the area where I live. Literally, I could walk to some of these. They're that close to my house. So we've got links and so forth. We've got some imagery for you. But let's get into the story. Berkeley, California-based Deep Fission, that's the name of the company, and Australia-based Endeavour Energy, which is an electricity network company, have announced a strategic partnership that will offer a unique approach to powering data centers through nuclear energy. And their goal is to bury small, modular nuclear reactors 1 mile underground. Now, I've inserted a little side note, my comment. A key trend to watch, and Ben, you're very aware of this, a key trend to watch is the development worldwide of small nuclear reactors, specifically to power energy-hungry data centers. And then I went out and I asked Microsoft's Copilot AI a question about who today is making small-scale nuclear reactors. And in the show notes, you can go and check this out. I've got, I think, about 10 companies. There's GE Hitachi, that's a big one. Westinghouse Electric Company. Tons and tons of people all over the earth are really working on these small nuclear reactors. But overall, these small nuclear reactors that are in development and some being deployed as we speak, still require, they're above ground and they require a lot of containment, but I'm jumping ahead of myself a little bit here. But that's an interesting list of companies.
Yeah. And everyone's working on it. There's even a story, and I know it's small nuclear fission reactors, which are going to be very, very important in the future. And then I even saw stories just a couple days ago that fusion, which is something that has come up every now and again in our stories, is also something to keep an eye out.
Yeah.
So the world of nuclear energy is certainly booming in a good way, not in the bad nuclear booming way, but yeah.
Yeah. That's a good one. So Deep Fission, one of the two companies involved with this, is pioneering this new approach. And they have designed, and this part's really wild, they've designed a small reactor that can be lowered into 30-inch diameter boreholes drilled a mile deep, 30 inches. Get out your, tape measure there and realize how small that is. And this method takes advantage of the natural geological properties at that depth, a mile down, as the Earth provides robust containment and constant pressure. Now, this eliminates the need for the concrete structures typically used for containment in above-ground nuclear reactors, both large and small, which significantly reduces the cost of construction and minimizes the environmental impact. Isn't that something? So once you drill this mile deep hole and you put the reactor down there, you're good to go as far as containment goes. That's what I think is so interesting. And then to wrap this up, a little quote from Elizabeth Muller, co-founder and CEO of Deep Fission, noted, quote, "Our technology not only ensures the highest levels of safety, but also positions us to deliver zero carbon continuous power at a cost about 5 to 7 cents per kilowatt hour." So, friends, again, the key trend, small reactors. Here's a twist. Put them a mile down in the earth and you get around the whole containment problem. Pretty curious and pretty interesting approach.
Yeah, and much more environmentally friendly. I'm assuming just a 30-inch hole, which is not the smallest hole, but still very, very small when you're talking nuclear power. And if you're watching on the video portion of the show, you can see what it actually looks like there. Just this long. Honestly, it looks like a pen with a cap on. But obviously, this thing's going to be much bigger than a pen. But still, it's very impressive that they're able to get the entire process of a nuclear reactor into this tube-like shape. It's very innovative.
Absolutely.
Like it a lot. So there you go. So there's story number 3. It's nuclear power is hopefully just going to be here sooner rather than later. That'd really help out a lot of people. So story number 3. Story number 4, we're going to go ahead and as Ralph likes to do, and I'll steal his thunder here and just say that story number 4 generally goes to medical science and medical technology breakthrough, things that make people's lives better, easier. Either it comes to better like replacement limbs or new cancer research or new ways to treat certain diseases in the body using new magnetic waves or something like that. Ladies and gentlemen, there's so much research going on in the medical field that I'm glad that Ralph really dedicates story number 4 to the medical field and science and technology. So let's go ahead and head on over to story number 4.
Yeah, story number 4 comes from scientistlive.com, a great site. And the headline here is New Biomaterial Offers Treatment for Central Nervous System Injuries. Wow. Okay. How can you resist this headline? Biomaterial. I see that kind of headline, Ben, and I go, I've got to know what's going on.
For sure.
So here's a little setup. This news is all about how a new electrically active transplantable material, a material that can help regrow cells in the brain and spinal cord, could redefine the recovery prospects of patients who sustain life-altering injuries or suffer from neurodegenerative diseases. Talk about something that's important. That one paragraph captures it all.
That's a huge promise, and pretty much everything they just said, like they said, life altering injuries and neurodegenerative diseases, like things that are not curable and really have, we have even just started to, help and improve. And they're saying, hey, this could aid in that. So
Yeah.
love the opening.
Yeah, this is really cool. So going on, it says a new 3D piezoelectric cellulose composite invented by experts at two universities in the United Kingdom, the University of Bath and Keele University, can be used to make a scaffold that's custom made for a specific individual. Though this is a very deep, very complex story. And again, the show notes will point you to the links in the paper that they published to get into the real details. So I apologize for just kind of glossing over, but we'll try to get the essential news out here on this. So the research team has demonstrated that neural stem cells derived from an individual patient can be precision delivered to injury sites, helping to effectively repair and regenerate neurons and associated tissues crucial for recovery. Wow. Good old stem cells.
I have noticed, and I was going to say that I've noticed a lot of, the research that, we've talked about over the last couple of years, Ralph, has been this ability to turn, cells from the patient into stem cells of the patients and inject them back in. Like that is a huge breakthrough that we're seeing everywhere.
Yeah, you're right. That is a key trend. We've seen it multiple times, and this is a nice new twist on that. And earlier we mentioned that this is a new 3D piezoelectric cellulose composite. And just a reminder, folks, the term piezoelectric refers to the ability of certain materials to generate an electric charge in response to applied mechanical stress. So there's a lot of things going on in this new invention. So the team of engineers, chemists, and neuroscientists from the two universities say the material offers the potential to create new treatments to help restore the motor, sensory, and cognitive functions of people who have suffered central nervous system injuries or neurodegenerative diseases such as Alzheimer's and Parkinson's disease. Wow.
Want to be able to cure that? Definitely want to be able to cure that.
That alone is just a showstopper. I love it.
For sure.
Now, the composite material we're talking about is made of cellulose and potassium sodium niobate piezoceramic particles. And I had to read that really slow because that's a mouthful.
Yeah, you've probably seen that at Home Depot on the shelf. The cellulose, the potassium sodium niobate piezoceramic particles. Of course, everyone's seen those. That's yes.
Yeah, right. So the scaffold implants that can be created with this new composite material look like small paper-like tubes, which could be custom made for the individual patients. And the key to the composite's clinical potential is its versatile, multifunctional nature and the use of cellulose, a widely available structural component of plants and algae, which means it's highly sustainable. So this is like a win-win-win-win-win on all five fingers of my hand. Total win, sustainable, based on the patient's stem cells, personalized, delivered into injury areas to regrow tissue. I mean, what's not to love about this and to leave you feeling really upbeat at the end of our show today?
Yeah, it definitely seems like not so much an issue of sourcing the material, because let's face it, humans are probably made out of some pretty readily available stuff. There's billions of us, but it's definitely more of the application and this idea of the piezoelectric, which, Ralph, when you think of, the human body, where you have nerves that when you press on things, you get a signal sent to your brain. Hey, that is piezoelectric. So I understand why they would want to make the material that, could possibly bridge that gap in injured people. So no, this, if they even do part way to finding further advancement to curing the things that they promised, this is an amazing breakthrough. So very good, and congratulations to the two universities for working on this. This is exciting stuff. So for everyone out there who has been following along with the show notes, and you can see there that's story number 4, which we try to keep it condensed for listening ease. Ladies and gentlemen, there are more stories in the show notes, and these are the honorable mentions. These are, of course, stories that are not worse, less. If you're a researcher out there and you hear your story on the honorable mentions, don't worry. It does not mean that you're not doing good stuff. It just means that we don't have time. So how about this, Ralph? Let's go ahead and give the nice folks the headlines to the honorable mentions. And if they'd like to find out more, come on out to the show notes and you can find links to everything. So, Ralph.
Yeah, this first one, and we're going to do 4 honorable mentions. This first one comes from sciencealert.com. Irresistible headline. Get this. Open world games like Zelda can boost your mental health, a new study says. Check that out. Look, it's one thing to go run around shooting people or something on those games. No, but open world games, they claim, can help boost your mental health. I thought that was just an intriguing concept. Next one comes from worldhealth.net. Worldhealth.net. Headline, Achieving Bone Regeneration and Adhesion with Harmless Visible Light. What a headline. And this is a really interesting story. Very involved, very technical, but you got to check this out. It's some great research that once again offers hope for a new path to repair fractures and so on. So check that out. That's a good one.
The trick with that one, Ralph.
Our next one is from interestingengineering.com. And the headline here is World First Sci-Fi Electric Motorcycle Could Fly for 40 minutes at 62 miles per hour and land vertically. And the image of this, if in the show notes, you got to see what this little guy looks like. It's kind of cool. And there's so many things. Ben, you know this. There's so much going on in the area of electric motorcycles, electric drones. What if you took an electric motorcycle and combined it with a drone? Here comes this bizarre product, which I think looks really cool.
It just immediately kind of reminds you of like E.T., where it's like, something the size of a bike and then it just takes off and just starts flying. Not that it's using, aliens, but yeah, I guess that's what it's going to feel like essentially is just hey, a little bike that lifts off the ground. That's crazy.
Yeah, that is pretty cool. It's a cool looking product. And it's indicative of a trend in this area of having the fusion of vehicles and flight. And we've been seeing stories, as you know, about flying cars and all this sort of thing. Well, this is a flying motorcycle that's pretty cool. It has a contained cabin, which I think is smart because that way the participant is protected from the elements and so forth. So it's kind of this crossover fusion, which I think is really fun. And then last but not least, our last honorable mention for this week, also sciencealert.com. Headline, Meanings of Words have been detected in the flicker of individual brain cells. Meanings of words have been detected in the flicker of individual brain cells. Wow. There's so much research, Ben, many stories over the past, couple of years. So much work on monitoring brain waves and figuring out how to make somebody be able to use their mind to generate speech and all this kind of stuff. This is somewhat kind of related to that whole world of research. A great, great story. So please, folks, come out, get the show notes at computeramerica.com and check it out.
Absolutely. And yeah, Ralph, they're only so far from being able to read our minds, like literally just strap something to your head and just read your mind, which would be both, liberating for some people and scary for others. But hey, we're not here to scare you. We're here to uplift you. And Ralph, you picked an amazing slew of stories today. I want to thank you so much for coming on the show and discussing them with us. And for everyone else out there, again, computeramerica.com if you have any questions. And with that being said, I hope you have a great weekend. You do something fun. We'll catch you here next time. Everyone, be safe, be good. See you then. Bye, everyone.